Hey guys, this is Mr. Wang. So I'm taking this video for you guys to explain some concepts and just basically teach you a lesson on YouTube. So the reason why I'm doing this, as you know, that I have to stay at home for 2 weeks because I have just recently traveled back from China where the coronavirus has been spreading, even though I'm not actually in the city where the virus is. But it's a kind of a precaution that we have to do because the virus is spreading out pretty quickly. And interestingly, like just how the timing of things is because it's also the Chinese New Year, so that's where everybody travels. So it kind of came out like pretty quickly. But yeah, if anything like this happened, in 200 or 300 or even 400 years ago, maybe half of the population will have got the disease and die, just like the Black Death. Like back then, people did not know what's going on and what caused it or how to prevent it. So, but nowadays we know, and thanks for science, and we find out like, well, how does these things behave and why does that happen and how do we like cure it? So if we can't cure it, at least the least thing we can do is try to contain it, which basically is what they're doing in China at the moment. So I've read a book last year, and basically it's talking about how human has three biggest enemies. So one enemy is a war. So if there's a war happening and lots of people is going to die, and it's almost like there's nothing you can do about it. The second thing is famine, and then the third thing is epidemic, like a big disease. So for famine, we've pretty much thought out the problem, because even though the Earth's population have increased so much, but through biology, through agriculture, we learn how do we breed things together to make things like a bit bigger. Say, I got some bananas at home. Like bananas didn't used to look like this big and very sweet and very tasty. It used to be really, really small, and but we were able to crossbreed these things, and through science, through the knowledge we have, to be able to to grow big bananas and also tasty ones. So, and through that, we've pretty much solved the problem with famine. We can grow a lot of food just on very small piece of land. And so the third one is epidemic. So even if we can't solve the virus, we can't cure it yet, but at least we can do is we know how it spreads, so we can try to contain it. So that's why I have to stay at home for 2 weeks, and it's part of the thing that the government has decided to do. So, but I'll be back with you guys very soon, and hopefully it will cause as little distraction to you guys as we can. So I'll try to teach you guys just online for now. And so I've given you the notes so you can copy down. So this is normally how I teach a class. So I give them the notes. As I'm going through in the notes, I tell them the concepts and giving you some examples at the end. Then I give you some time. Maybe watch a YouTube video, maybe do some experiments. We have some experiments. And if they're at the end, I give you guys some time to practice some questions. Okay. All right. So it's a good introduction. So you guys through last year 10, you probably know what science is all about now. So, and I personally believe science is not just about remembering some facts. So some physics, some chemistry or biology. It's rather just really figuring out how things work. So as we find out how things work, we can improve, and we can use it. And so, for example, one typical example is I was looking at the TVs the other day, right? So TV used to be really big, and how does it work? If you shoot the electrons out, and then you land the electrons on a screen, and they shoot out really fast. It makes some light, and then we can see pictures, and they do it that way. But nowadays TV are very small because we found out about LEDs. We can use LED to make light, which makes it way more efficient, and also the color just become way better as well. So this is how we use science, right? So we find out about it and we use this. So, but in order for us to use it, we have to know the basics, because science has been there for a long, long time, and constantly people find out about new things, and then we use that to help us to learn. So, okay, so this lesson, we want to talk about two fundamental ideas in physics. One is called a scalar quantity, and one is called a vector quantity. Okay, so what is the scalar quantity? So in physics, we have a lot of quantities. So say my mass, right? How much I weight, my weight, even my glasses, like that is a quantity. I can say I got 200 degrees or 2.1 or minus 2.1, however you want to call it. So that is a quantity. A quantity measures something, right? Okay, so when we measure the quantity in physics, there are two types of quantity. One is scalar. Scalar quantity only have size. So for example, a typical example, let's use my weight as an example, my math as an example. Okay, so I weigh, I think after Chinese New Year, probably 79 kg or 80 kg. I've gained some weight. So 80 kg, and this 80 kg is just a number. It does not have a direction, right? My mass is not going that way, that way, that way, or this way. The mass is just here. Mass is all the substances that I have, right? So, or my age, for example, my age is an example, like that is a scalar quantity, only have size. Well, I was 32 years old last year. Now I've gained 1 year old. Now I'm 34-year old, right? 33 plus 1 is 34. Yes, okay. So, so that's a scalar quantity. Scalar quantity, 1 plus 1 always equal to 2. Okay, but we have another quantity we name it called the vector quantity. Okay, so what is a vector quantity? Vector quantity is a quantity that not only it has size, it also has direction. Okay, so for example, force is a typical example of a vector quantity. So if I say, well, a force is 10 Newton, and this force could be pushing, going this direction, or it could be pulling, going this direction. I can move the cup this way with the 10 Newton force, or I can move it this way. So this 10 Newton force really has a direction. So any vector quantity that has a direction, if it has a direction, we call it vector quantity. Okay, so let's give it an example. So another example of vector, let's say velocity. Okay, so if we talk about speed, we say it only has size. So what does that mean? That means if a person is traveling at 20, say, meter per second, and that 20 meter per second tells me how fast it's going, how fast it's changing its position, but it does not tell me what direction it goes. Okay, that's only the size. But if we want to specially mention the direction it's going, so we have to add a direction. Then we give it a new name. We call it velocity. So if it's a velocity, that means it has a size and direction. Okay, so if a question asks you, say this, what is the velocity of the car? And you cannot say it's 20 meter per second. That is incorrect, because you can say the speed is 20 meter per second, but you have to say the velocity is 20 meter per second going north, because that direction matters. Okay, all right. So for a scalar quantity, 1 plus 1 always equal to 2. Okay, for example, time. Time is a scalar. If I had 1 hour, now another hour passed, so 2 hours has passed. 1 plus 1 always equal to 2. So, but if we talk about a vector quantity, 1 plus 1 can equal to 0. Okay, so it does not necessarily equal to 2. I give you guys an example. Say force, right? So force is a vector quantity. It can be 1 plus 1 equal to 0. Let me give you a situation. Say I got this cup sitting on the table over here. Okay, so now moving. And this cup over here had a gravity of 1 Newton, or like say 10 Newton, pulling it downwards. Gravity is pulling it downward. But the table is giving this cup a support force, say also 10 Newton. And the 10 Newton going down and the 10 Newton going up, actually they can cancel each other, and then the total force of the cup is actually 0. So you can see with this kind of concept, a vector quantity, actually the direction really matters. So that's why we have to consider the direction. We cannot just simply add 10 and 10 together. So does that make sense? Okay, so let's look at another example. So now we talk about distance and displacement, right? So you've seen the nodes. So if I talk about distance, distance is a scalar quantity. So we only care about how much you've moved, okay? So if you go this way 5 meters, you come this way 5 meters, total your distance is 10 meters. Okay, so but if you are talking about something called displacement, so displacement is where you are from your original position. So we're comparing this whole thing. So say this, if I'm here and I move this way 5 meters and I come back 5 meters, actually now my displacement is 0. That's because I'm back to the original position. So displacement, as we've known it, it's a vector quantity. We have to consider the direction. Okay, so over here, so we give you the distance and displacement definitions. And same idea, speed and velocity. So if you use distance divided by time, you get the speed. If you use displacement divided by time, you get the velocity. So velocity has a direction and speed does not have a direction. Okay, and then if we're dealing with one-dimensional situation, so what does one-dimensional mean? So one-dimensional is like this. Say if you're going to the left and then you're going to the right, and that's one-dimensional because it's either left or right. That's one-dimensional, okay? So, but if you have like this, say you're going north, south, west, east, and this is two-dimensional because you're going two dimensions, okay? And so our space, as you know, is three-dimensional because I can go forward, backwards, left, right, up, and down. So I have this three axis. If I have three axes like that, three axes, so that is three-dimensional. So two axes is two-dimensional, x and y, right? If I only talk about x, either left or right, then it's one-dimensional, okay? So this year at year 11, we are only dealing with one-dimensional situations. We don't deal with two-dimensional, so it's a lot easier, okay? So let's have a look at this one-dimensional situation. So how do we deal with it? We need a method. And this method is, sometimes we can say, well, if this y is positive, and then this way will be negative, okay? Just like when we draw the arrow with the arrow on here and I put x on the side. Remember in math we draw this kind of diagram, x on the side. Okay, if there's a 0 in the middle and then this is positive and then this side will become negative. Okay, say you go from here, you went 5 meters this way, and then so your displacement is 5, and then if you went this way 7, so now your displacement become -2. Okay, so 5 and 7 now become -2, okay? So, but if you talk about distance, that's 5 and then 7, so the total distance you travel is actually 12. So that is the difference between a displacement and distance, okay? All right, so now I've given you guys another example. Say, all right, let's say this is 0, okay? So if you are on this side, you're positive. Okay, remember this side is positive. So you're on this side, you're positive. If you keep going to the positive side, so right now your displacement on this side is positive, okay, because you're on the positive side. And then your speed is also going the positive side. So right now your speed is positive, your displacement is positive as well. But if you're going this way, you're heading to the negative direction. So right now the speed is negative because you're going to the negative direction, or your velocity is negative, but you're still on the positive side, so your displacement is still positive. And when it's over here, your speed or your velocity is still negative, it's still pointing to the negative, but you are sitting at 0, so your displacement is 0. And when you come over here to this side, so now you're on the negative side with your displacement. Your displacement is from 0 to here, so it's negative, and you are pointing at the negative side as well. So once you go to this side, say you're coming back again, when you're coming back this way, remember this is 0, and you are sitting on the negative side. This is a negative side over here, and then however your speed is pointing to positive. So right now you have a positive velocity, but a negative displacement, and then you're hitting here. Now you're having 0. Displacement is 0, and then your speed is positive again to the right. So that's how we analyze it, using a positive and negative to determine the direction. So it's just easier for us to use it in the future. Okay, so this might sound a bit confusing for now. So, but after a little bit of practice, and you'll get to use to this kind of like thinking. So really, with science and with physics, it's not just teaching you a basic like things for you to remember, rather it teaches you a method, it teaches you a way of thinking. So the more you think about it, the more it starts to make sense, and then you can use these concepts to go analyze other skills. Okay, so unfortunately I cannot answer any questions here because I'm doing this video lesson to you guys, and obviously you guys can send me an email, and then my email is v1, so it's VWANG, so VWANG at apps.x.school.nz. So if you have any question, just send me a message anytime. And I hope you enjoyed this lesson. If there's any recommendations you guys like to give me. So any feedback on how the lesson went, and please let me know, and I can adjust my videos accordingly. So obviously I'm not some kind of YouTube star, and I watch YouTube videos quite a bit, and it's actually a bit strange for me to take this video just like this. But I hope like this will help you guys learn today's concept. Yeah, and on the note, I say, well, I'm supposed to take you guys out for a run around the physics block, and then you will see like, well, your displacement is 0 because you're back to the physics classroom, but you have, but your distance was, 50 meters maybe around the physics block. So obviously we can't do that today. And yeah, so I hope you enjoyed this lesson, and I'll see you guys in the next video.